This is my favorite calculator, a HP67 from 1976. It has everything a calculator needs, all the mathematical functions, and it even has a magnetic card reader that actually works. But there is one problem. One of the segments is not working. Now the display here consists of 3 chips, each one with 5 digits. It was quite a work to find out the correct part number of this display chip, and then it was another adventure to actually find one somewhere, a working one, and yeah, I found one on eBay. Let's see how that looks like. Well, I found one in the Little Diode eBay shop. That's a guy from England who has all kinds of obscure semiconductor parts, diodes, chips, stuff like that. And it seems it was the only one available because it is a little bit special, of course, for that calculator. And well, that's how it looks like. I noticed that even this, well, it is not new, but it has a problem. The last decimal point here doesn't work. But that is not a problem for me, because I can put it here on the very right side here, and there no decimal point is needed. And I move that display to the middle display, which is, wait, which one is the wrong one? 1, 2, 3, 4, 5. No, it's the first one, so I have to exchange the last and the first to correct that problem, and then take that one with the defective decimal point to this position where no decimal point is needed. Yeah, let's do that. The original part number 1990-0335 can be found in the service manual, but HP changed this part number to 5082-7400 series. And if you know that, it's relatively easy to find a replacement, but well, there are both versions are pretty rare. As you can see, they come in 2, 3, 4 and 5-digit versions. And even the 5-digit version, which I need, has 2 different flavors. And that is, one has the decimal point inside the digit and the other one has it right to the digit. So we need for this calculator the one with the decimal point inside, because, well, it looks strange if one digit is different than the other. I also converted the original nickel-cadmium battery to a lithium-ion battery here. There is a short video on my channel about how I did that. That's pretty handy, because the original batteries are most likely not good anymore, and nickel-cadmium always have a lifetime of a couple of years. So that's a solution for that. Now, where are the screws? 2 screws are here, underneath these covers here, that are a little bit tricky to remove. Then we have more screws, and if I remember right, there are 2 are here under these pads. Yes. And there are two more underneath this one. You can see I have already opened that before when I cleaned everything and did the conversion for the battery. A little professional tip: always take a small container for the screws and the tiny bits, so you don't lose them, and you can also move them all away if you need. Two more screws. And 5 and 6. Okay, and we're in. So what do we have here? That's the motor from the card reader. It says Swiss made. Well, good mechanical parts come from Switzerland, we all know that. Here is the card reader chip. It's the motor driver, the head amplifier. I don't know if the motor driver is inside the chip. Then we have, I think that's the main CPU down here. And the little chips here, that's the ROMs with the programs. And we have a DC-DC converter here. So we have to get to the display. It has these interesting contacts here that go through the PCB to the contacts on the other side. Let me see, that lifts off like that. That is all connected, so we have to unscrew this plate here. Yeah, at least they have the same screws everywhere, so we can't mix them up. That's good. I think it's also 6 screws. There is another one. And there is number 6. These golden pins here, that's the connector for the charger, the original charger. That doesn't work anymore. Okay, so that's the keyboard and display PCB. It is connected with 2 wires, unfortunately. So is it just lifting out here? Yes, I think so. Come on. Yeah. When you're working on these old calculators here, always make sure you took a photograph of the keys here, because these are all individual keys, and if they fall out, you have to know where every key goes. So that's another tip when working on calculators or keyboards like this. Okay, and here we have the displays. 3 of them. Hard to find today. And interestingly, they are mounted in an angle. They are not straight on the PCB. That is perhaps a little bit difficult to replicate, but well, it should be possible. Let me first unsolder these wires, because I fear if I don't do that, they will break, and then I have to repair them too. Okay, I'm ready to desolder. I took a new tip here for my desoldering iron, one that is smooth, has no cracks and no scratches and so, because these solder spots here are tiny and old, and I don't want to damage them with a scratched up tip. So let's see how well that works. Okay. Okay, that went easy, so I hope the rest works like that too. Now the next step is to take this chip and place it here, because the new chip has a defective decimal point, but we don't need a decimal point. We don't need a decimal point here, because here is only the exponent that has no decimal points, or in the program mode the program steps, which also need no decimal point. So we take this one here. So it says 1990-1335. Okay, well, if you can see that, yeah, I think that works. The new chip I have has no markings. Maybe someone cleaned it a little bit too intensively. And look how they actually bent the pins here. That's already a work of art. I don't know if I can do that, but I will try my best. So that's how they made this angle to the board here. I guess they have a tool or a small machine that bends the pins, and yeah, that's exactly how it has to fit. Alright, I just decided that I can't bend the pins exactly how they did it, but if I just insert it and lift it a little bit. Yeah, it's a little bit off. No, well, I can tweak that quite a bit. Yeah, I think we can do that. Okay, that was that. Let's put it together and see if it still works. I hope so. Okay, moment of truth. Let's put the battery in, turn it on. Yeah, it still works. 88888. No! 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 Wait. Did I just replace the wrong one? No. It's still the same segment missing. Wait. Wait a moment.
One eternity later.
Okay. I spent about half an hour studying the technical manual of the HP67. That's the same calculator but with a printer additionally. And then I looked at the footage again and I realized I'm dumb. Okay. Well, maybe not so dumb, but it's difficult. When you look at the beginning of the video, we see that the 5th place is faulty. 1, 2, 3, 4, 5 must be that display here, right? No, because the first is blank, because they use it for the minus sign. So 1, 2, 3, 4, 5. It's this one here. That's the bad one. Okay, let's replace this one. And then we hopefully have a working calculator. I already showed you how this soldering works, so we don't need the camera for that. And it makes everything a little bit easier for me. So wait a minute.
A few moments later.
Okay, now we have that good one, which I already tested on my power supply. All segments are working. And the other good one goes in here. Yeah, that happens when you assume something is in a certain way. I was really sure that the 5th number is the last number on the first display, but it's the first number on the second display. Yeah, that's stuff that happens. Well, because it can only be the LED display, because if the PCB track is broken, all the same segments in every number would be missing, and even the HP manual says so. By the way, I have to show you that manual because it's really fantastic. It has oscilloscope pictures. It has everything you need to repair this calculator. and they really did a lot of, they also put a lot of tests in the manual and stuff like that. So they really wanted that engineers can repair that calculator. Well, that was an expensive thing back in the day. I think the HP67 was about $400 something in 1976. That's quite a lot of money. I think it's about $4,000 today, maybe 2,000, but that's certainly not something you throw away when it's not working correctly. So you bring it to a repair shop, or if you are an electronics guy, you start repairing it yourself. Alright, moment of truth. If everything works, we should now have a perfect display. Exponent 88. Change the sign. Yeah, finally. Everything works. Yeah, it's easy when you replace the right chip. Problem is gone. Now, I'm interested. Please tell me in the comments how many of you have seen that coming. How many of you have realized that I'm actually replacing the wrong display chip? Well, before I realized it. I'm curious. Let me know.